have finished 3.13 finally. Now we're going into 3.14. We're going to do it for 2 days, and then don't forget Friday will be a homework check, a work day. Guys, Friday will be a homework check, a work day. I'll introduce the polar equation project to you, and it could be a makeup day if you're making up that quiz from 5 years ago. Okay, so that's what Friday will be. And so today we're going to actually learn how to graph polar functions. Polar functions have the r's and the thetas in them, and we're basically going to use 2 different methods, okay? We're going to use a plot pointing method, which is kind of, you don't even really have to think too much. You plot points and you graph them. But then we're going to use what we see in these graphs to know how to do the other way, which just takes a few seconds, okay? And you'll just mostly do, well, I'll explain that more in a second. And I'm also going to relate to you as we get through how you'll be asked these questions on the AP exam, because it's very, very minimal, okay? But let's start out by saying, all right, we're going to be graphing in this beginning here, this polar equation. And to do that, a table of values was made for us, and some points were chosen, some thetas, and we're going to find the r's that go with it by plugging in. Now, if you're really good at the unit circle and you don't need, like you can just come up with it in your brain, totally fine. Just to remind you though, sometimes if you have to, like, because we're making 2 XY charts here, one's got sine, one's got cosine in it, and you can see these are quadrant 1 and quadrant 2 angles. If it helps you to maybe just have something written down ahead of time, just a piece of advice, not required, you might want to just have, you know, something to quickly glance at. All of your denominators of 6 are that ordered pair. All of your denominators of 3 are this ordered pair. And I'm not going to bother writing the denominator of 4 because that wasn't included in our list here. But one thing I always like to have, so me being someone who, I know that I don't need to write that personally. I know those quickly in my brain. But one thing, if I do mess up on, it's going to be the quadrantals. So I really like to draw myself a quick quadrantal graph. So I have sine and cosine just looking at me. I can just quickly glance over there and I'll show that to you as we go. And I've told you that before, but that's even if you don't need to write that down to have it to reference, this is super helpful because you think back, you know how many times you've mixed up the 0 and the 1 and that kind of thing whenever we've had to do things like this. So let's go ahead and start plugging and chugging. So we're going to plug in our first theta, which is 0, in first theta, and do sine of 0. So looking at this, I can just quickly come up with what sine of 0 is. And don't forget what you already know. Cosine is your x value, sine is your y value, right? So sine of 0 would be 0 times 4 is 0. Okay? So I'm plugging in 0 for theta, so sine of 0, that's here, right? This is the angle 0. Does that make sense, Levi? Right here, this is 0, that's pi over 2, that's pi, that's 3 pi over 2. So at 0, my sine value is 0. So then I have 4 times 0, which is 0. Okay, keep on going. Sine of pi over 6, that would be 1/2. 1/2 times 4 is 2. Half of 4 is 2. Sine of pi over 3 would be the square root of 3 over 2 times 4. Don't forget, with multiplication, you don't need a common denominator. You just multiply straight across, and 4 over 2 becomes 2. Sine of pi over 2 is 1. 1 times 4 is 4. Now I'm transitioning into quadrant 2. Notice I didn't write out the whole 2 quadrants. I don't need to. I know that 2 pi over 3 is this same ordered pair, except that the cosine is negative. Well, I'm not even dealing with negatives in this, or cosines in this problem, so I don't care about that. I'm still just using positive sine right here. So 2 pi over 3, sine of 2 pi over 3 would be this, square root of 3 over 2 times 4 is the same as we got here. Sine of 5 pi over 6 is 1/2 times 4 is 2. And sine of pi would be 0, and 4 times 0 is 0. So we made an XY chart, our theta chart, and I'm going to plot the points just like we learned how to do last week. One value I want to just see, if I put 2 times the square root of 3 in my calculator, just so I can have a decimal equivalent, because how do we know what 2 square roots of 3 is? So 2 square roots of 3 is approximately 3.5. So I'll use 3.5 here and here. Okay. So let's remember how to graph these. So remember, the way we graph is r theta. So anytime r is 0, it doesn't matter what your theta is. Your point is at the pole, is the origin. All right. Now look, there are concentric circles going on here. There are 2 axes, and quadrant 1 has 3 lines in it. The ones we used at the beginning of learning this only had 2. It doesn't change what happens in that quadrant. This would be a denominator of 6. Excuse me. This would be a denominator of 4. This would be a denominator of 3. Not that you have to label it. Okay, you don't have to. But remember, this line was missing in the last one, the one we did this before. It wasn't really missing, we just didn't draw it. But we just knew that in between those two would be 4. So don't overthink that too much. All right, let's keep going. So out at pi over 6, I would go out 2 circles. At pi over 3, I'm going to go out 3.5 circles. So, do that. At pi over 2, I'll go out 4. Here's another denominator of 3, right? 2 pi over 3. That would be 3.5 circles. Oops. At 5 pi over 6, which would be closest to the x-axis, I would go out 2 circles. And this, my friends, makes a circle. Okay. Not perfect, not even pretty. You will see my lack of artistic skills in the next few days, for sure. Let's do another one of these, and then we'll talk about it, and I'll show you the easier, quicker way of doing these. So, sketch the graph of -3 cosine theta. So again, I look at my table of values. I've got some quadrant 1, quadrant 2. Actually, it's the same ones as here, so I'm just going to use this information I have up here. So, at 0, I want cosine of 0. So cosine is the x value, right? So that'd be 1. So 1 times -3 would be -3. Pi over 6, use a different color. Pi over 6 cosine would be square root of 3 over 2 times -3. Do that. Cosine of pi over 3 is 1/2. 1/2 times -3 is -3 halves, or -1.5. Decimal would be fine. Cosine of pi over 2 is 0 times -3 is just 0. Okay, now we're in quadrant 2. Be careful because cosine is negative in this quadrant. So at 2 pi over 3, cosine of 2 pi over 3 is -1/2 times -3 is positive 3/2. Negative times a negative. Cosine of 5 pi over 6 is negative square root of 3 over 2 times -3. Negative times a negative is positive. We get 3 square roots of 3 over 2. And cosine of pi is -1, and -1 times -3 is positive 3. Let's plot them. So in our first example, we had all positive radii, so we didn't have to shoot through the origin. Don't forget, whenever your radius is negative, you do have to do that extra step. So going out to angle 0, right, this is 0 out here, 0 or 0 pi. We would go out 3, but we don't get to stay there because the radius is negative, so I shoot through the origin and I end up right there. -3 square roots of 3 divided by 2, I put it in my calculator to get a decimal equivalent just to make it easier to graph. would be around 2.5, okay? So at pi over 6, which would be here, I would go out about 2.5 circles, but don't forget, you don't get to stay there because it's negative. So you shoot through the origin, and you would end up, let's say, about here. Okay? It's exactly the same denominator of 6, but in the opposite quadrant. Pi over 3 would be up here, and that would be 1.5, but we don't stay. We shoot through, and we end up here. Remember, same denominator, different quadrant. Whenever your radius is 0, that's how many circles do I go out? 0 circles. Who cares what the angle is? And now these are positive. At 2 pi over 3, which would be up here, I would go 1.5. At 5 pi over 6, that would be here. I'll go out positive 2.6, so I don't know, here. And then out at pi, I would go 3. That's a duplicate point, and that happens sometimes. Okay, sometimes you have the same point more than once. And we have a circle. So what you should know is that when you get one of these two equations, and they're the most basic of the polar functions, those are circles. Okay, so that's one thing you need to know. And what I want you guys to notice is this. This is really important. I feel like last period some people maybe weren't listening or just didn't catch on to this part, and it's the key to all the graphs. It's how you start every single graph. So what I'm about to tell you is super important. Not difficult, but you kind of have to look. I want you guys to remember something. Cosine is x, sine is y. And think about the x-axis as like a cosine axis. It's not really, but just for a second. Cosine, sine, right? X is cosine, y is sine. If you notice, our sine graph, this 4 sine theta, notice all the points are symmetrical around the y-axis, the sine axis, if you will, and it's above 0. That's because the 4 is positive. If the 4 had been negative, your graph would have ended up down here, okay? Look here. We have a negative and a cosine. So cosine is left or right, and since it's negative, it's to the left. If this had been a positive 3, all your points would have ended up over here, okay? That's going to be key in starting all the rest of your graphs, okay? Plus, when we get to the homework, there's 2 circle ones to do, and you don't have to plot points anymore, okay? You're going to have a shortcut way of doing this graph in literally a second. As long as it takes you to draw a circle, that's how long it takes you to graph these. This was important to know so you could understand how these are made, and I will tell you, the FRQ on our last test is one like this. You know, find the points, plot them, and then answer some questions about them, okay? We're not going to answer a bunch of questions today. We're going to go a little deeper into them tomorrow, but all I do want to write is this next part in C. If you have R equals plus or minus A cosine theta versus R equals plus or minus A sine theta, the positive or negative A matched up with whatever word is there tells you which way it's going to go. So for cosine, if your A is positive, you go up. If A is negative, you go to the right. So sorry, that's to the right. Sorry, I was thinking about sine for a second. Cosine is right or left. So cosine is to the right and positive, and then negative cosine goes to the left. Positive A on sine goes up, negative A on sine goes down. So cosine is left or right, sine is up or down. And you need to know that for all the other graphs we're about to do. And I'll show you that momentarily. Don't write this next part, but I just want to remind you, back in like Algebra 1, you would have learned slope-intercept form, right? And you might have even started graphing it using a table of values. And that's always valid. You can graph any function using a table of values and plotting points. So plug these in, just like we just did a second ago, except they were a little bit fancier, but same idea. But then you learned a shortcut. You learned M and B, and you graphed your B first, like your y-intercept, and then you did like, if it was 1/2, you go up 1, right 2, right? There was a quick way to do it. But you could always do this, okay? And that's kind of the idea. Here's the fallback method. You're totally lost, you could always sketch a graph. But there are quicker ways of doing it. So the next page is page 168, but we're not doing that page today. Save it for tomorrow. That'll be the first page tomorrow. We're actually going toward the bottom of page 169. So today you're going to learn all the different types of graphs. We just did circles, and now we're going to do cardioids and limicons. Tomorrow we'll do rose curves, which look like flowers. Okay. All right, so here's the thing. This is really, really important that you know this. I'm going to teach you some stuff about these, and at first you're going to be like, what? Like, how am I supposed to remember all this stuff? By the time I'm done, you're going to think it's really, really easy, especially when I tell you what's expected of you on the AP exam, which is no graphing, okay? On the AP exam, you do not have to graph any. There will not be an FRQ that involves polar graphs. No FRQs on this. It will all be multiple choice. So let me make that sink that into your brain for a second. And then when we're done with the notes here, in a few minutes, I will explain why we're graphing these and how it would look for you. Okay, so just trust me, trust me. I taught this twice today. Everyone thought it was so easy. They got it done super quick. So just stay with me and learn this. You'll get your homework done and you won't be stressed. Sorry, did you guys have a question? Do you have a question, Bill? Oh, okay. All right, so we just learned about circles. Okay, circles was R equals A cosine theta or R equals A sine theta, basic graph. Notice what these equations look like. R equals A plus or minus B cosine and or sine. Okay, so now we're introducing another variable, B, and there's going to be a plus or a minus. Okay, so look ahead to what those look like. So you can easily tell the difference between the ones we just did and these. Now, in this category, there's 3 types. Okay, we do not need to know the names of them. We're not expected to know the names. It's cardioid, limicon with an inner loop, and dimpled limicon. You do not need to know those names. I gave them their own little nicknames for us to remember. Okay, so just stay with me. First thing is this. Remember we just talked about the direction according to the sine or cosine and whether it's positive. This would be considered a positive cosine. Positive cosine. Since it's a positive cosine, it means we're going to go to the right with the majority, if not all of our points. And how we tell how far we go is really simple. We add A and B. A plus B is 4. That's where your first point goes, to the right 4, right on that cosine axis, if you will. First point. And that's going to be the first step in every single graph, okay? We're not doing symmetry in any of these. The second step in all of these graphs is to find the ratio. The ratio is the A value over the B value. And we only care about positive. So from here on out, everything I talk about with any of these, we don't care about signs. The only thing the sign does in these graphs is tell you if you go right, left, or up, down. After that, we ignore the fact that there's a negative if there is. So this is 2 over 2, which is 1. Anytime your ratio equals 1, it's going to be a heart. And I'll help you remember this in a second, but think of 2 people in love, their heart becomes 1. Their heart becomes 1, okay? It'll help, trust me. Next thing you need to know is the A value, which in this case is 2. And this is going to be the same thing I say for every single graph. And I'm calling it my own little term here, is axis width. What this is we always put our first point on one of the axes depending on this. The other axis that we haven't touched yet, that's how wide the graph is going to be on that. So it's going to be up and down 2. These graphs are very, very symmetrical. Very, very, very simple to graph. And there's only one more point you need to remember on a heart, and that's you always have a point at the pole. And that's it. You're going to make a heart out of this. Now it helps me to be able to turn my paper, up to you how you do it, but you simply make a heart out of those points. And that's it. That's your graph. The reason I called it axis width, for a while I was like, let's just call it width. I was trying to come up with easy ways to memorize these. Because by the way, your friends that took this in the past had this whole reference sheet that they could use when they graphed. They didn't have to memorize anything. But I'm going to simplify it for you. Don't worry. Trust me. Trust. They had to do a lot more work than you guys will have to do. Believe me. So instead of calling it axis, just width, because it really goes wider than 2 if you think about how wide the heart goes. So just understand I'm calling it axis width, so that's the other axis. Let's do another one just like it so you can see the differences and the similarities. So this is a negative sign. What direction is that one going to go? Down. And it's going to go down, A plus B. Don't worry about signs. From here on out, we ignore that there's a negative. We're going down 4. So down 4. First point on that y-axis. Our ratio is going to tell us what type it is. Okay, so A over B is 1. 1 is a heart. Okay. The A value is 2. That is going to be your axis width on the other axis that we haven't drawn anything on. And a point always on the pole. Think about it, a heart in between the two people, right in between them. And then you draw a heart. Oh, that's a good one. They get really bad for me. You'll see. I'm horrible at drawing. Horrible. Okay? So that's the first of 3 types, determined by the ratio. Okay? Whenever the ratio is 1, it's a heart. Okay? Next page is 170, so some of you have to find it. It's a green piece of paper for some of you. Sorry, I'll give you a second to find it. Okay, same idea, right, we're going to go to the left, it's negative cosines to the left, 1 plus 2 is 3, absolute value on everything. So we're going to the left 3, that's where our first point is. Let's do our ratio, so that would be A over B, all absolute value. That is less than 1. Whenever your ratio is less than 1, it's called a loop. Less than loop, L's. Less than loop. A is 1. Again, same idea. The axis I haven't drawn on, I'm going to go up and down 1. And there's one more piece I need to help you understand that. Let me show you what a finished loop looks like. Looks like that. It's got a loop in the middle. So we need that point where it's going to make the loop. That's going to be in between the axis and our first point. There's going to be a loop somewhere in between these. How you find it is B minus A. Always absolute value. I'm not going to write it every time. So that would be 2 minus 1 is 1. Now, right away, as I say it every class, I'm like, I'm sure I can read their minds. Like, how am I supposed to memorize all this? You're not going to have to. So just, I promise, if you trust me for a little bit longer, it'll make more sense in a second, okay? So I'm going to have a point in between that axis and there. Knowing that this is going to make a loop helps me know, okay, I'm going to put a point there, not up there. How would I make a loop if it was over there? You'll see what I mean. And so, again, I have to turn my paper or else I can't do it. So you're making a loop, like a little fancy heart, kind of. Maybe like crossover. What direction will D go in? Up. How many, Sabine? 3. Up 3 is our first point. Ratio will tell us what type of graph it is. A over B is less than 1. That is a loop again. A is that width on the other axis. And B minus A is 1. Where do I put the 1? It's going to go in between the, in this case, x-axis and our furthest point. because you have to have a loop in there. The closer they are together, the harder to make the loop. Do the best you can. You will not be graded on how pretty your graph is. Oh my gosh, I'm getting really good at this. I don't mean to brag, but that's a good loop too. I'm getting really good. Maybe I am an artist at heart. What do you guys think? Wait till you see the last one though. For the life of me, it's embarrassing. I cannot draw these. Okay. Last one. We have to the right, cosine positives to the right. 3 plus 2 is 5. First point to the right, 5. Ratio is A over B, which is greater than 1. This is the only one left. I don't have a cute way to help you remember it. I'm calling it a dimple. It's called a dimpled limacon, but we're just calling it the dimple one, okay? And then A is 3, so 3. Now, with the loop, we put our point down here somewhere. With the dimple, it actually goes on the other side, okay? Again, do not stress about that. I'm getting ahead of myself. We need one more point. Where that point is going to go is where I just said, but the way we find it is A minus B. How am I supposed to remember if I do B minus A or A minus B? You're not going to have to stress about that. Trust me, trust me, trust me. I will get to that. So that means I'm going to go this direction. It's more spread out. The dimples are bigger, okay? Let me show you what this is supposed to look like, and then I'll try and graph it. It's like a heart with less of a dip in it. It's called a dimple. It's like a peach, kind of, if you can picture that. But, again, I'm not grading you on how well you do. I cannot do these. It almost looks like a guitar pick when I draw it. Almost. Okay? So it's not so much of a heart, like taller piece there. And if you were doing a table of values, it would look a lot better, right? Because you'd have these points all like, you could graph them. But they'd still be like decimally, so it would be hard to make it perfect. It'd probably be better than this, but we don't care about that. All right, last one. This would be down 7. Ratio 5 over 2, of course, is greater than 1. This is going to be a dimple. A is 5. 5. 5. A minus B is 3. Do I put the 3 down here close to the other point? Nope. Dimples are the ones that are really more spread out. And that's it. Here's what hers looks like. I don't think it's that much better. So, see what I mean? They're not easy to graph. Even artistic people, I mean, that's horrible. That's full credit, though. Okay. So let me explain something to you guys before we sum it up, and then I give you the homework and start with you. When it comes time for the AP test, these are multiple choice questions. This is what you'll see. You'll be given an equation. Let's do like this one. You'll be given this equation in 4 graphs. What you'll see is 4 graphs where, for example, this is one way you can see it, where one's going left, one's going up, one's going right, one's going down. Okay? So they're all loop problems, and you would have to know which direction it's going in based on like this information. Or, same idea. Given this question right here, you have 2 loops and 2 hearts, you know, left and up, 2 different shapes. So you're not, this part right here, this, are not super important because it's multiple choice. I've never seen, they're not going to be nitpicky about that. It's not like they're going to have one, look guys, they're not going to have one like where the loop happens at 1 and another one where the loop happens at 2, something that slight. Do you see what I'm saying? I'm giving you lots of minute detail so you understand them. If you go to BC, you go really deep into these. Some of you are skipping AB, going to BC. You're going to be ahead of the AB kids because they haven't done these in a really long time since they had me a couple years ago. So, or from them a couple years ago, last year. So just understand this is going to help you with your project, knowing a little bit more about it, help you with your homework, all that stuff, but don't stress so much about that stuff. What's really important is our ratios. So let's sum it up. Your 3 different ratios you could get, and knowing what the shape of the graph is, that's important. Right? Equals 1 is a heart. 2 people together in love, 1 heart. Less than is a loop. Greater than is that weird dimple one. All of them have A as the axis width, and I made this term up just so you know. I mean, there might be an official name or something, but for our purposes, that makes sense. And A plus B is your, what should we call that? Distance, directional distance. That's that first thing we do. All of that is the same for all of them. So that very first thing we did, A plus B, the last one was 7. So that's really what is important. Can I sketch these graphs or identify a sketch of these graphs with this information? That's what key is, okay? So let me show you your homework. Oh, if you've been given green papers before, you need them now for the homework. This is the rest of the paper. This is the last time I have to deliver to you. So if you are someone that needs page 174 and so on, let me know. I did directional, what did you do? Directional distance. Oh, sorry. Thank you. Directional distance, I meant to write. Directional distance, sorry. Do that. All right, you have all the green sheets you need, but guys, from here on out, anytime you have an even page, you're going to have to go to a green sheet. It's all the evens. I'm sorry that happened. All right, let me do the first 3 with you, and then you can finish without any problem. So notice the first 2 don't have that plus or minus in them. That was the first graph we learned how to do, which was circles. We're not going to make a table of values right now. We're going to use what we just learned about loops and dimples and hearts to graph these. So first you should identify that 1 and 2 are circles. That's important. That means that they are a circle. And negative sign means I'm going to go down, right? Just like the other ones. How far down do you think I'm going to go with what I have there? 4. There's only one number, guys. Down 4. And if you blink, you'll miss it. So look, here it is. Okay? Circles are our favorite. Okay? How about this guy? Which direction am I going to go? Right. 3. Make a circle. And so notice these circles don't cross the other axis. They all touch the pole. So you have a point there and a point there. That's it. Okay? And the last 5 that you're going to do are the different, see how they all have the pluses and minuses. So think about your direction. 2 plus 2, our A plus B is our directional distance, I guess I'm calling it. So directional distance. That's the first step in all of these. You can even go right to the second step in all of them, no matter what type it is you know you're going to have this. Now what do you do with it, right? That depends on the ratio. Since it equals 1, this is a heart. So this is what you have to remember with a heart, because you have no other points to graph, is that it will have a point at the pole. Okay, the heart will always have that point there, and then you just do this. Okay, I will put the others up, including that one if I went too fast. Let me know if you have a question.